For as long as we've looked up at the night sky, there's this one point of light that's just brighter than almost anything else. We call it the morning and evening star. It's our neighbor, Venus. But what if I told you that the most beautiful thing up there is also, hands down, the most terrifying place in the entire solar system? And that right there, that's the whole paradox of Venus. I mean, on the one hand, it's named for the Roman goddess of love and beauty. And it fits, right? It's got this calm, silvery glow. But science, well, science calls it something else entirely, Earth's evil twin. And believe me, as we're about to find out, that name is scary, scary accurate. So, to really get why, we've got to go way back to the very beginning, because this is basically a tale of two planets, siblings, really, born from the same cosmic dust, but oh man, they ended up on completely different paths. And the wild thing is just how similar they were at the start. I mean, we're talking 4.6 billion years ago, Earth and Venus pop into existence from the same cloud of gas and dust. For a while, they were probably a lot alike. In fact, some scientists think that for a little while, there might have been two blue marbles, two planets with liquid water oceans right here in the inner solar system. Which really makes you think, It shows that just being in the habitable zone isn't the whole story. Because fast forward to today, and one is a paradise, and the other, a total inferno. Okay, so before we get to all the scary stuff, let's just nail down how strong this family resemblance really is. Because if you just look at the stats, on paper, these two planets are almost identical twins. All right, let's look at the tail of the tape here. You look at their diameter, their mass, what they're made of, silicate rock and iron core. It is an incredibly close match. We're not talking about comparing Earth to a giant like Jupiter. No, this is like Earth looking at itself in a really, really twisted funhouse mirror. And just to really hammer this home, Venus is 95% the size of Earth. For all practical purposes, they're the same size. So if they started out the same and they're built the same, what in the world went so horribly wrong? All right, so if they're the same size, made of the same stuff, how did one go so wrong? This is where the story takes a really dark turn. We're about to pull back those beautiful, calm-looking clouds and see the absolute hellscape that is the surface of our twin planet. So you might want to brace yourself for this. First up, the heat. The average temperature on the surface of Venus is 462 degrees Celsius. That's 864 Fahrenheit. I mean, that's not just hot, that's melt lead into a puddle hot. Seriously. And okay, if the heat doesn't get you, the pressure absolutely will. The pressure of the atmosphere on the surface is 92 times what it is here on Earth. To put that in perspective, imagine being 900 meters, that's almost a full kilometer deep in the ocean. That's the kind of crushing force we're talking about. You'd be flattened in an instant. So why? Why is it so incredibly hot and dense? Well, the culprit has a name: carbon dioxide. The atmosphere on Venus is more than 96% CO2. That's what's created this monster runaway greenhouse effect, the most intense one in our solar system. For comparison, Earth's atmosphere, less than 1% CO2. Oh, and yeah, it gets worse. That super thick blanket of CO2 is topped with clouds, but they're not made of water. Nope, they're made of sulfuric acid. So you get this incredibly corrosive acid rain, but it's so hot, the rain actually boils and evaporates before it even hits the ground. It's just a completely toxic alien sky. Back in the 70s and 80s, the Soviets sent these probes called Venera. And somehow, miraculously, a few of them actually survived long enough to send back pictures from the surface. They're the only photos we have. And they show exactly what you'd imagine. This desolate, rocky wasteland, completely crushed and superheated, all glowing in this weird, eerie orange light that's filtering down through those thick, toxic clouds. Okay, so that's the what. It's a hellscape, plain and simple. But now for the big question, why? What happened? What does the scientific autopsy of this dead planet tell us about how it became the evil twin? The answer has a name, and it's a chilling one: the runaway greenhouse effect. Think of it like a planetary point of no return. It's a positive feedback loop that, once it gets going, it just doesn't stop. It just keeps getting hotter and hotter until the whole planet is completely sterilized. So how does a planet-wide catastrophe like this even happen? Well, here's how you boil a planet, step by step. It starts out pretty small. Venus is a little closer to the sun, and over millions of years, the sun gets a bit brighter, so its oceans start to evaporate. That water vapor goes into the atmosphere. Now here's the kicker, the tipping point. Water vapor is a really powerful greenhouse gas. So more vapor in the air means more trapped heat. And more trapped heat means, you guessed it, even more evaporation. It becomes this vicious cycle that just feeds itself, getting faster and faster, until the oceans literally boil away into space. And once the oceans are gone, there's nothing left to absorb all the CO2 that's being pumped out by volcanoes. So the CO2 just builds and builds and builds until you're left with the permanent, sterile pressure cooker we see today. And this is where we see the crucial difference. The one big thing that may have saved Earth from the same fate: plate tectonics. You can think of it as Earth's global thermostat. Our crust is broken up into these plates that are always moving around, sinking under each other, recycling themselves. And over millions of years, this whole process actually pulls carbon dioxide out of the air and locks it away deep in the Earth. Venus, though, it has what scientists call a stagnant lid. Its crust is basically one solid piece. So when its volcanoes belched out tons and tons of CO2, there was no system to clean it up. The carbon just stayed in the air, piling up, unchecked for billions of years. So, okay, this is a fascinating but tragic story about a faraway planet. But why does it matter so much to us right here, right now? Well, it matters because Venus isn't just a planet, it's a warning. It's the ghost of a world that has a profound and, frankly, terrifying lesson to teach us about our own home. And here's the lesson. A habitable planet is an incredibly delicate thing. It's not a given. The exact same greenhouse effect that keeps Earth cozy and alive is what sent Venus into overdrive and boiled its oceans away. It proves that a planet's climate isn't just naturally stable forever. If you push the chemistry of the atmosphere too far, you can hit a tipping point, a point of no return. The line between a paradise and a pressure cooker is just terrifyingly thin. When you really think about it, looking at Venus is like looking at a ghost. It's the ghost of a path Earth could have taken, but thankfully didn't. But it's also a warning for our future. It's this powerful, silent, scorching hot reminder hanging in our sky telling us to pay attention, to understand and protect the incredibly fragile balance that makes this world, our world, possible. You know, when astronomers are out there searching for life, they're always looking for Earth-like planets. But Venus teaches us a really important lesson. Earth-sized is not the same as Earth-like. You can have a planet with all the right ingredients, all the right building blocks, and it can still end up as a sterile inferno. Being habitable isn't a permanent state of being. It's a precious, fragile thing. And that leaves us with one heck of a question to ask ourselves every single time we look up and see that brilliant star in the sky. Are we doing enough to preserve our precious, fragile home?